Okay, welcome to my talk, 10X Your Whole Team, Lessons from 100 plus years of lean manufacturing. How many of you work in a factory or know what lean manufacturing is? Yeah, okay. Great, perfect, this will be a great talk. So when I think about lean, this quote from Deming is probably the most apt way to think about it. How do we work smarter, not harder? Especially when we talk about factories. So for those of you who've not worked in a factory before, in general, factories are pretty simple. Raw goods come in and finished goods come out. That's pretty much it. And the science, we'll call it, of doing this efficiently is what I like to call lean manufacturing. Many people think lean manufacturing started with Henry Ford in 1913 when he patented the moving assembly line. But it's much older than that. Henry Ford built on Ransom Olds, who patented the stationary assembly line. But it's much older than that. 1525, the Venetian armory could pump out 1 galleon per day, which was much faster than the old Roman record. But it's much older than that. The terracotta army was buried with 40,000 almost identical bronze arrowheads, which research has shown was probably produced in a circular manufacturing setup. And I'm sure this goes back much further. This was the oldest record I could find of a manufacturing line. But China has a special interest for me. I grew up in Guangdong, China for 8 years when I was a kid. My mom was running a factory over there, and so we lived there for a long time. Right now, I'm the owner of CyberMedics. We do custom software for businesses. But yeah, I grew up in China in the 90s, and there's a lot of change. This was the road to Shenzhen in 1992, and 6 years later in 1998. So I've kind of been immersed in this culture of constant improvement and growth, and that's really why I love this lean stuff. So let me give you a modern history of lean manufacturing. I like to call this scientific management meets labor crisis. This story starts in 1941 in the US. We just got into World War II. And you can see our national labor force, which includes unemployed people, employed people, and the armed forces, drastically ramped up when we entered the war, mostly because our armed forces increased by so much. We ate into the unemployed category a lot, but you can see the trends there. We had 10 million people enter the workforce between 1941 and 1944. That's a lot of people who didn't know how to work in a factory, and we had a lot of demands. We had to build tanks and planes and bombs. So where did those people come from? Women, this whole new workforce that had never worked in the factory before, but it was now expected to hop into these brand new jobs and produce really important munitions for our war machine. You've probably seen Rosie the Riveter. That was a contemporary poster to these. But all these posters have in common the War Manpower Commission. This was a commission that was actually established by President because we had so many labor problems. So the War Manpower Commission ran the selective service during the war, which is the draft. But more importantly, they trained labor for jobs, and their mandate was to increase labor efficiency. We had to build more tanks, more bombs, more planes with workers who didn't know how to work realistically. So one of the divisions of the War Manpower Commission was the Training Within Industry division. And these are, they consider them the 4 horsemen of TWI. I don't know why, but they invented a system where if you were a factory owner, you could go to the TWI committee and they would train you on how to train new employees. And not just train them, but also solve personnel problems and improve your own internal processes. So they did that through these 3 different colored kind of checklists. And this still exists today. You can go get trained on TWI, and it's really a great way to do training in companies once you guys make it to the workforce. But the blue one was on how to train other people. The yellow one was on how to fix problems with personnel clashes. The green one was how to improve processes. And together, This was kind of a scientific method on how to increase your factory's output during the war. And it worked really well. In fact, there's this really great video, which it's 13 minutes long, so I'm probably not going to show you the whole thing here. But this was, let's see, is it going to play it? Of course it's not going to play it. I even ripped it off YouTube so it would be local. That's fine. It's a cute video. It was done in 1944, which is kind of the peak of this labor crisis. And it takes the story of a young woman starting in a manufacturing plant with a boss who couldn't care less about her. He throws her at the machining press and says, "I'll be back in a few hours." And when he comes back, of course, she's done all the work wrong. And so then it kind of jump cuts to, well, how should that have been done? And it walks you through the TWI process of, teach them why you're doing something. So it starts with, this little piece looks unimportant, but it's a really important piece of an airplane. Here's how it screws on to its piece, which is why you need to drill the hole on this side. It's a really fun video. Wish there was at least a title slide so you can look it up on YouTube if you're interested, but you can look it up. It's TWI. I'm sure you'll find it on YouTube. 1944. It's cute. Oh, there we go. I just had to hit the button. No, I know. This is why we're doing this today. Again, it's really long. I'm not going to take you through the whole thing. Okay. But then the war ended. 1945, 46, Japan surrendered. And guess what happened to all those workers? Fired. They left. They went home. Yeah, pretty much fired. So the story goes, most of the men came back. They went back to their old jobs, and the factory workers said, or the owners said, forget about all this TWI stuff. You're back. Great. We're going to keep doing things the way we've always done things. And so the president actually disbanded the War Manpower Commission. The TWI team tried to keep doing things in the US, but the factory owners didn't care. They had some success in Europe, but things really changed when they went to Japan. So the war ended. We know about the nuclear bombs, but what you might not know is in March of 1945, we firebombed Tokyo. This was the single deadliest air raid in the world, still to this day. And shortly after that, of course, Japan surrendered. Terrible loss of life, but also a terrible impact on Japanese economy. If we look at this, starting in 1935, we kind of see a nice growth in Japanese industry, and then they lost the war drastically. And once we won, the U.S. kind of stuck around in Japan and kind of had a terrible foreign policy where it was like a punishment policy, and it just got worse and worse. And things weren't looking very good for Asia as a whole. Unfortunately, or fortunately, China was kind of struggling. It looked like they were going to have a civil war. Russia was pretty powerful at this point. And the president realized, well, maybe we need to have a democratic country in Asia to help us hold our assets. So in 1947, we reversed course with Japan. MacArthur kind of dictated that Japan was going to have a democratic constitution. And we started investing in Japanese industry to kind of stabilize the area and help rebuild the country. So guess who showed back up? The TWI team was contracted to bring all of these factory improvements from the US over to Japan to help them increase their production quality. And it worked. It worked great. It worked really well. This graph goes to 1956, but it just keeps going very, very fast. By 1980, actually, the US was in a bad spot. Our cars were more expensive, lower quality. Japan had just taken over the chip manufacturing title from the US, and we kind of entered into the US-Japanese trade war at that time. And in, I think it was June of 1980, this was on primetime news. This goes on for an hour and a half, but you might recognize that quote. That's Deming, his first kind of public speech, if you will, in front of the country. This is in 1980, after he went for the last 30 years in Japan to help kind of rebuild their economy. This was a really cool piece. Again, you can find it on YouTube. It's public domain. But essentially, our labor hadn't changed from 1945 when all the 46 when all the men came home. We threw away all of this modern ideas and just kind of did what we had been doing our whole time. Whereas Japan really soaked it in. I mean, they didn't have much choice. We were kind of there to help them, but we taught them how to do manufacturing the way that we thought was the best possible way to do it, and it really stuck. After this kind of crisis, the Japanese companies came over here to teach us how to run factories. And they brought along the blue TWI job book and said, why don't you do this? You taught us how to do this. And we've kind of picked it up as a country and really embraced this lean manufacturing principle. So that's kind of the modern history of lean manufacturing. Next, I'm going to go into what lean actually is and how it's going to impact you guys in your careers. Any questions on the history before I keep going? Okay. All right. We're going to start off. Lean principle number 1, defining value. This is the most important piece of lean anything. Let's go back to our factory. Raw goods come in, finished goods come out. None of you guys have worked in a factory, but if I simplify that a little bit, I think you'll find this relates to pretty much anything in life. There's a process. Something goes in, something comes out, and hopefully value's added during that process. This could be the process of you studying for a test, the process of an API request, going through a few servers, whatever it is. It's really underpins everything. But what is value? Lean defines value in 2, maybe 3 ways. Number 1, a customer is willing to pay for it. If you're doing something and nobody's willing to pay for it, you probably shouldn't be doing it. Number 2, delta. It should be a change. You need to change the good. If you don't change the good, you're not adding value at all. And number 3 kind of is the legal side. If there's a legal requirement that you have to meet, or maybe an internal business rule or something, maybe the customer's not paying for that, but you need to do it to stay in business. So that is also part of value. So what's the opposite of value? Waste. And lean classifies waste in 8 ways. And you can think about it. Mr. Tim P. Wood, who's a real guy in the UK. I found him on LinkedIn last night, so I feel bad for him. But realistically, any waste you could think of in a factory or anywhere really can be categorized into one of these categories. May as well go through them. So transport would be a waste where, let's say I have goods coming in right here, but the workstation's all the way over there, so I have to take them with me over here. I'm not adding any value to anybody doing this, so that's a waste. Inventory, this is a classic one with lean, but if you haven't been exposed to it, the more inventory you build up, that's a bad thing, because that inventory is sitting there taking up space. Things could happen in the marketplace and you might never be able to sell the inventory. So lean says the least amount of inventory that you can accumulate, the best. Motion, any sort of movement that I'm doing as a worker or anything, usually isn't adding any value to something. Personnel is a good one. If I have a highly trained engineer and I ask them to do a menial task, then I've wasted all of that training that I gave them. But we see that a lot. You guys might not have had office jobs before, but so much time is spent filling out forms and just typing stuff into spreadsheets, and usually that's all waste as well. I mean, perhaps that whole form could have been automated from your personnel file plus a few other things. So there's a lot of personnel waste out there. Waiting's pretty obvious. Overproduction, if I make too much of something and then nobody buys the rest of it, that was a waste. Overprocessing, if I do too much to something but nobody cares, probably shouldn't have done that much to it. Defects, that's pretty obvious. In fact, defects is a big one too. If I do a bunch of work and then it gets to the end of the process and there's an error, and I have to do it all over again, that whole first run was completely wasted. A good example of this was ordering pizza for tonight. I tried to order pizza from NYPD Pizza. And I went online and put in the delivery date and set up my whole order and went to check out, and it said, we're closed on Mondays. You can't have this order. Why didn't they tell me that in step 1 when I put my data in? That was a defect, I'm going to say. It may have also been over-processing, I'd say, too, because I didn't care about that order after they told me they were closed. So I shouldn't have done all that work to type it in. OK, so lead principle number 2 is a good one. Process mapping. So in the beginning there, I showed you that little box with the inputs and outputs. Imagine we expand that a little bit to show you a whole process. This is basically a flow chart. You've seen a flow chart before. This is a good one. Am I a horse? I think there's a little bit of waste in this flow chart personally because both of those go to the same place. I can probably eliminate that whole part there. But you could see it's a bit of a process to figure out if I'm a horse or not. Could be a technical process. This I kind of stole from, I don't know, Roomba or Dyson or somebody. I forget what article it was, but this was the logic that you might follow for your robot vacuum. Now, there's some color on this thing, but I don't think the color really means very much. But think about those 8 wastes. Could you find any wastes here? As a consumer who's buying this vacuum, do I care about all this stuff? Is there something the vacuum has to do that, like, I couldn't care less? Maybe you could eliminate, I don't know. This is a pretty small flow chart, so it might be hard to do it. But think about it, right? I've mapped out a process, and then I'm going to look at this process and say, is every one of these steps adding value? Or is it one of the wastes? And if it's a waste, how could I remove it in the future? Here's a process of building software. Personally, I like to do this with sticky notes. I got my whole team together the other day, and we put together the process of developing software at CyberMedics. And I use colors to talk about waste. And so all the red things there were all the places that we looked at our process and said, we don't need to do this. Nobody cares about these things. We can eliminate them from our process. So I have an exercise for you guys, 10 minutes here. Think of a process in your own life that needs some improvement. Use your pen and paper to kind of draw that process map out. But we're trying to draw the current state here, so don't eliminate waste just yet. Try to figure out like exactly what am I doing today so that you actually see the wastes in front of you. It's really powerful. And then pick a neighbor and kind of talk through your waste process. So let's see, it is 6:49. I'll give you 5 minutes to do your drawing, and then we'll switch over to presentation mode. What's my typo? Wastes. Weights. It does say weights. Watts. Just going to say do not skip waste. You got that chair. Play some music or something, I guess. I could do that. I have my thing. What? I should play some music or something. It's a little high. What? I'll flash a red light and Jeopardy music will start playing. All right, I see some pens coming down, although I still have 30 seconds left based on my time frame. Fifteen seconds left. Okay, great. Good work, everybody. All right, part two. Pick a neighbor and take turns explaining your process to each other and identifying any waste that might be in there.
Know you have homework. If you don't, acknowledge it and then do it. If you do, plan to do your work, follow the plan. You know, just basically distractions. If you follow the distractions, you're probably gonna get it done late or not at all. If I don't, you're gonna get it done time.
Okay.
Not following the plan also makes you not doing it in time or not at all.
All right. So it's like a four.
Where might there be waste in that process?
This entire part.
Very good.
And technically, if I do an error, he would just not know I have some homework due. Then
very good.
That just kind of immediately he jumps from here to here.
Yep. Fair.
Feeding the cats, got a lot of steps. Kind of like double-digit cats.
12.
Yeah, basically that's a good guess.
Oh, was it actually 12?
Yes, it actually was 12.
Oh.
But so the
software engineering at like a company that does hospital billing, like overpayment and stuff like that. So we kind of analyze all their overpayments and we kind of build our UI for them to do that. That's cool. I do all this starts after 6 o'clock.
otherwise, and you got to portion it out to each cat.
Yeah. Basically, I think I can find something else to organize it. I can just do this with the app or just do it once a week instead of doing it every day. I kind of look through my calendar every day just to make sure I haven't skipped anything. But other than that, I think, and then trying to put on like a timer on my phone or something, that would be those are the wastes for me.
Very good.
I know you can automate it, but it's like what, $500 investment or something crazy.
I know. All of these snoozes.
I can't explain it, but I know those are the same way. Like the TV thing. I don't know.
We only actually have to
Well, I know you can't do the drawing part of this, but
That's okay.
is it?
Talk about it.
Is it? Yeah. Tell me about your process.
I say that today's two ways will probably be the access link because of the fact that they couldn't find building 7.
Really? Yeah. Well, neither could the pizza. That's a pretty bad one.
Because they were able to find like building 10 and 11.
Yep.
And the driver found building where she saw the sign says 7 to 9.
Yeah.
So we came back and then after I guess at a certain point she finally found the building.
Well, that's good. Well, now she knows. Maybe next time it won't be so bad.
And then the second waste was after coming into the building, I thought room 7122A was the correct room,
Oh.
realizing that there was another room without the letter. So
Interesting.
if the building was had actually a directory and arrows, because I know some office buildings they actually have it
Yeah.
where they'll tell you, okay, room 100 to let's say 120 is
Yeah.
to the left, and then the one to the right, and so on and so forth. So
Yeah.
if there was a better mapping system on
Pardon me.
campus, it would have been easier to find the room.
The room. Very good. What would you change about the process, if you could?
With regards to the building itself, obviously, if they have a directory out in the front
Yep.
and the main lobby, that will actually present a much easier time for people who are looking for classrooms, especially if it's their first time. With regards to the layout of the campus itself, visually, I'm not sure how it's laid out, so I wouldn't know, first of all.
There's a big number on the side of each building,
Okay.
but from certain angles you can't see the number. So they tried, but it's not very good.
So if that was the case, then maybe somebody would just
Or-
have numbers on all sides of the building.
Each building could have its own address. The whole campus is one address, and then it's just building 1, building 2, building 3.
Exactly what I was saying earlier.
It's bad. It's bad. It's a bad process getting to Valencia. For a commuter campus, you'd think they would be much better at this, to be fair.
But I guess that's because of the fact that it's Florida, because there's more land, so therefore, they keep the entire campus as one address and then have each building numbered.
I don't know. They could have numbered the buildings. I don't think that would have been very hard, but maybe the post office had rules about how many addresses they could pull.
Could be. I mean, I remember looking at, for example, the networking class that we were doing. For example, if you were to create a network within an organization such as Valencia College, obviously, you would have to have locations for each of the sites, but they would have to have their own IP address.
Yep. Subdomains.
Because each building had their own buildings, and then each building has several floors, so you have to add some subnets.
Yep. Sub addresses. Numbers in the address. Good. Well, I'm glad you're following along. We'll see how you do on the next part. All right, folks, excellent conversation. Please wrap it up in the next 2 minutes. That's a locked door now. Must be a timer lock. It was open earlier. All right, everybody, we're going to have to keep going here, so head back to your seats. There's lots more to learn. Wonderful. Okay, great. So what I hope you got out of that was how fun it is to draw things on paper once in a while. And it's nice to see a process, and it's really easy once you've got every step mapped to go, oh, that one probably shouldn't happen, or this one has some problems with the inputs. Whatever it is, it often helps to just draw it out. You saw my picture earlier with the Post-its. I like to do it this way so that way when you realize, oh, there's a step in between those two, you can just move them over and put another one there rather than committing it to paper. And when I do this with big groups, we'll go all the way around the room if the process is big enough with Post-it notes and, oh, that one's hard, there's a lot of waste, put a red one up there. It's really fun to kind of map out your processes. So now that we have a problem that we'd like to fix, the next thing I'm going to show you guys is the idea of continuous improvement. This is how lean methodology says you should fix these problems that you guys have all identified. I think perhaps the best way to explain this is perhaps an old wives' tale, but a professor teaching pottery decided he was going to run an experiment with his class. At the beginning of the semester, he separated the class into two groups and said, group one, you guys only get to make one vase, but you can study all year long on how to make the best possible vase. Make that one vase and give it to me, and you will be graded on how perfect that vase is. Group two, I don't care how good your vase is, you'll be graded on the weight of vases you make over the semester, so make as many as you want. So the end of the semester came, and group two had made hundreds of vases, and group one had produced their best possible vase after months of research. Well, group two had a much better vase because they had practiced making vases and learning all the problems with making vases over the whole semester, whereas group one studied and did a lot of research, but nothing beats actually going out and doing it. Probably a fake story, but it does really illustrate the point. Come with me, if you will, in the journey of the imagination. Let's say that you're stuck in a giant warehouse with a flashlight, but it's not a very good flashlight, and it's a very dark warehouse. So you can't really see the other side of the warehouse, but you know there's a door over there that you're trying to get to. You look around, and there's stuff all over the floor. It's dangerous in this warehouse. How do you get to that door? Do you make a big plan on how to get to the door and just blindly get there? You're probably going to fall. What do you do? Here's what you do. Number one, you get the direction or your challenge. For you guys, it's whatever you put down on paper. For the warehouse example, it's knowing that there's a door. Two, you grasp the current condition. I look around with the flashlight and see, all right, there's stuff there and there and there. On your papers, you've mapped out the current condition of your process. Three, establish your next target condition. It's not the door at the other end of the warehouse. It's not the perfect process. It's where do I want to get to next? Maybe it's I'm going to get my homework done 2 days earlier than I normally would. Maybe it's I'm going to make it 5 steps toward the door, I think. And then you conduct experiments to get there. Probably what you think is going to get you there isn't going to work, and you're going to have to pivot halfway there and kind of work it out. It's okay. Like every step you take doesn't have to be the perfect step, but you do need to know where you're trying to go, and you need to be methodically getting there by conducting experiments. We call this plan, do, check, act. It's the PDCA cycle. Plan, I'm going to plan out what I'm going to do. I'm going to do it. I'm going to check to make sure I did what I thought I was going to do. Consider, did that get me closer to my target or not? Maybe I have to undo that. Maybe that process that we rolled out to the whole team made the whole team less efficient. We should probably not do that anymore. That's fine too, but we've learned something. And when we learn something, it's really important, I need to change the acronym, that we standardize that step. We write down the new standard work for making a pot or doing homework or whatever it is. You need to write it down, and you need to share it with everybody and say, this is the new best way to do something. Because if you don't, you're just going to slide right back down this hill of improvement. It's really, really hard to make lasting change. And it's really, really hard to make big lasting change. If I need to get from there to there, I'm not going to do it in one shot. I'm going to do it in small cycles, take small steps, make small improvements. And eventually you'll get where you're going. But it can be a rocky road. By the way, the idea of this small cycle improvement, the Japanese call it kaizen, or change good, Kai Zen. So you might have heard that term before. That's where it comes from. So when I map out a change, one of the tools that I like to use is this A3 document. And my slides are out of order a little bit. Let me go a little further here. Great. So the idea here is the Japanese call it an A3, and that's because that's the size of paper that you guys have in front of you, 11 by 17, also A3. The idea is that you fit everything about your problem on one piece of paper, much like drawing it out on the paper helps to kind of get it in front of people and tell your story. If you can map out everything that we've talked about, what activity are we doing, what value are we producing, what is the current condition, ideally with a picture, how are we going to take our next step? What's our plan? What's our plan to experiment? Where do we want to get? What's the desired future condition? And then ideally, at the bottom here, we actually have like a schedule with names on it. So, Garrett is going to do this by this date, and Jen is going to do this by this date, and that holds us accountable. If we look at one that I've done with a recent customer, I don't think the customer's on here. This was a problem we had where one of their systems only had 15 licenses, but we needed 80 licenses, and they weren't willing to buy them. So we were going to recreate the whole system in a different technology that didn't need licenses. And so we could see CyberMedics had a lot of actions on this one, but you can kind of read this and understand what we're trying to do and why it's important on one piece of paper. This is a great communication tool that's available to you. So exercise 2. Give me an A3 about your process problem that you've mapped out and how you're going to take the next step to solve it. It's probably not going to get you all the way to the future condition, but what's the next thing you're going to do? And when you're going to do it by? Can you read this? This is a good test here. Is it too small?
I can read it.
Okay. Okay. Good. A little change here. Sorry, to steal the slide. There we go. Let's see what change I made. So little. It's so little. Use the whole paper. This isn't a 4x3. This is an A3. Very small. It's true. I give you pens and not Sharpies today. Last time I did this, I used Sharpies, and then we drew all over the desks. So I figured that was probably not a good choice. Because they can't read your handwriting. It's the doctor's trick. What prescriptions is for? I don't know. Whatever you want it to be. It's bad. All right, I know I said 10 minutes, but I'm only going to give you 5, otherwise we're going to run over. So you got 2 minutes left. All right, folks, I'm not going to have you share your A3s with each other. This is an individual effort. But I will say this is a snapshot in time, this document. The idea here is that you would execute your implementation by following your key dates and deliverables, and then see where you are. You probably redo your A3 with your new future condition. Current condition is what was before, plus my learnings from there. What's my next step? Did we change our future condition? That happens sometimes. This is a very iterative process. That's why we call it continuous improvement. You never stop. You always keep going. A little bit better, a little bit better. And eventually, you're Toyota, and nobody can catch you on quality. That's pretty much it. So I've talked a lot about lean through the ages, ending basically in the 80s. We didn't have all the software and technology in the 80s that we do today. So lean's still around. It's not just a factory thing. Everything you do is a value-adding process in your life. Certainly what we do in software. I think probably one manifestation of lean in software is the idea of continuous integration and continuous deployment, CI/CD. You can kind of see the PDCA cycle in here. We plan, we build something, we release it, we measure it, check it, make sure it worked, and we do it again. And this is pretty much how software is delivered at a high level today. Al's talk has a lot to do about kind of this side of the delivery cycle, the continuous deployment integration piece. Jen's talk is going to be a little bit about the more technical building code side. But everything we do is continuously improving, and that really comes out of the idea of lean. In project management, as it relates to software, you may have heard of Scrum. You may have heard of Kanban. Scrum was really popularized in, I don't know when, maybe the late 90s, and it was kind of agile. You might have heard that term before. Agile really popularized Scrum. The idea was we would deliver something every 2 weeks. Lean kind of has a very different flow. It's continuous. We deliver something as quickly as possible. We reevaluate all the time. Use a Kanban board to do it. In business, Lean's really made a big splash about 10 years ago. This book came out. You can operate a startup using Lean principles, and your success rate is much higher than somebody who makes a huge business plan and then stumbles into something 2 days in. So it's a really great book if you're into entrepreneurship and want to own a business one day. Check this out. And then in IT, this book's fantastic. It talks about problems that really every technology organization has and how they can be solved using these principles we've talked about today at a more detailed level. It's actually a remake of a book written in the 80s about a factory that was a total mess and was completely revitalized using lean technology, but this is all IT related. Great book. And that's it. I hope you guys learned something today and can take something away. Thank you.
Contact CyberMedics today to schedule a detailed consultation, and let's engineer the future of your enterprise's digital evolution. Call us at 321-300-7130 or visit www.cybermedics.com.